In 2016, paper 1, question 6, it's differentiation. And the first one here is differentiation from first principles. So again, once we see first principles, we're going to be using the formula limit h goes to 0, fx plus h minus f of x over h. Now what would be advisable, this is our f of x. To do with this here is to square out the bracket. So f of x is equal to, write out the bracket twice, or square the first, 4x squared, multiply the two together, 4 times 2 is 8, times 2 is 16, and your 16x, and square the last, 16. That's the first bit. Now fx plus h, just simply sub in x plus h everywhere we have our x. Tidy that up again, do your squaring first, your brackets. Square the first, multiply the two together as xh and double it, and square the last. So again, that's the second bit done. Just go stepwise. We've got to subtract these. So this here, your fx plus h minus your original term, your f of x. And that implies your 4x squared. Oh, I'll just write it out. Minus all of that original term. Don't forget to change the sign of everything. And as you see, there'll be cancellation here. So your 4x squared with your 4x squared, your minus 16x with your 16x, and minus 16 with your plus 16. Now what you're left with, divide by your h. So you've got 8xh plus 4h squared plus 16h all over h gives us 8x plus 4h plus 16. And then your final thing, the limit as h goes to 0 of all that. That just simply means horse and 0 for your h. And you're left with 8x plus 16. And again, you know that answer's right from your differentiation. Multiply down by the power, 4 times 2 is 8. And reduce the power by 1, x to the power of 1, and 16 times x, blah, blah, blah. There you go. Now the next one is another differentiation problem. This time here, you can see two things joined together. When we see that, we're going to be using our product rule. And our product rule, UV, just simply states the first by the diff of the second plus the second by the diff of the first. So first by the diff of the second plus the second by the diff of the first. It's a lot easier than doing your substitution each time. Now a way to make this easier is to rewrite this before we look about find the derivative. X sine, and that's x to the power of 1 below the line. When you bring it up, it becomes x to the power of minus 1. Now when you're different trig functions, yes, you've got to remember these things. Power, function, angle. You go in that order. You get rid of the power when it's on the trig function. So if it's sine squared cos cubed tan to the power of 4, here we don't have a power on it. Then you diff the function, and then you diff the angle at the end. So here, as we said, it's a product rule. This is our first term here. This is our second. So look on page 25 of your formula book. Top rule, you see here in order to find the derivative of it, it's the first by the diff of the second. Now this is the tricky bit. Diff in this function. Have we got a power? No. Have we got a function? Of course. So the diff of the sine function here, you can see is the cos function. So we've only dealt with that, cos the x power of minus 1. And now diff the angle. This is your angle here, multiply down with the power, reduce the power by 1. And we'll tidy that up later. First by the diff of the second plus the second times the diff of the first, which is 1. Tidy that up now. Don't do too much at once. Cos x to the power of minus 1 simply becomes cos, how do we get this a positive power? Bring it down below the line, like you did in step 1. And here, minus 1 over x squared. Again, to get rid of the negative power, bring our arm down. Plus 1 times anything is going to be itself. So this is all we're working with. Sine 1 over x. Tidy that up. Generally, I'd be multiplying this term here by the diff of your angle. Minus x over x squared. Cos 1 over x plus sine 1 over x. And you can tidy that up. That's the same as saying, I'll just write it in, I wouldn't write this in the exam. Minus x over x times x. And you can see they cross off, so you're left with minus 1 over x. So dy dx is minus 1 over x cos 1 over x plus sine 1 over x. And the final bit of that question, part B, find the slope. Now everywhere you see slope, maximum, minimum, turning point, you know it, dy dx. Find the slope of the tangent to this curve, which we worked out the previous bit, when x is equal to 4 over pi. And get your answer in 2 decimal places. Right, use your previous answer. So if you made a mistake in this here first bit, still use it. So minus 1 over x cos 1 over x plus sine 1 over x. Now here, keep your answer in radians, 4 over pi, our calculator will take care of it. So wherever we see x, we're lobbing in 4 over pi. So when x equal to 4 over pi, dy dx, the slope of the tangent at that point is minus 1, 4 over pi, cos 1 over 4 over pi, plus sine 1 over 4 over pi. Just be careful you put that in your calculator.